Can we start, Ravinder?
Yes, ma'am.
So we have to all dear participants, we have with us Professor C.P. Gupta. He's currently the professor at Department of Financial Studies, and sir is having the teaching and research experience of over 40 years. His research include quantitative finance, investment management, and fuzzy decision making. And sir is also the nominated member of an expert group constituted by Government of India, and sir has numerous papers in his name, books, and for me, he's one of my uh, resource person and the guru who always guide us humbly, politely, and help us in learning
Anshika,
the
thank you.
research in a
Thank you.
easier way. Thank you, sir. Over to you, sir.
Okay.
Sir, we cannot see you. Your, I guess, video is not visible, sir.
Okay, I will do that.
No? और निधि की गाड़ी अंदर थी, तब आपने पीछे निधि अभी नीचे थी, तो उसकी गाड़ी निकालनी थी, फिर आपकी थी, तो वो फिर रिक्शे से गई। चाय पी लिया आपने? पीनी है? पीनी है?
Hello. Ashika, are you able to hear me?
Yes, sir. I'm able to hear you, and I can see you also, sir. Yes, sir.
Okay. Friends, very good morning, very good evening to all of you. And the mandate that's given to me, I have to talk about statistics and regression analysis using R. And that's what we are going to discuss in this evening session. Okay. Every session has a motive behind it. So this session, and let me share with you what kind of motivation I have behind designing my presentation with you people. Motivation of the session is understand research and analyze the data to answer the research questions. Because whenever you do the research, every research is having certain research issues or research questions, and we have to answer them. And we need data to answer those research questions. So how to analyze data to answer those questions, that will be our focus. Of course, we are not going to discuss each and every tool of analysis. We will be talking about some basic statistical tool for analysis purposes and regression. And the focus will be, we have to understand what we need for our research and how can we use the tools to answer those research. So friend, let's start our session with two thoughts. Thought number one, if you cannot explain it simply, you don't understand it well enough. And that understanding is very, very important. Of course, we have to do learning, but that learning should be with understanding. And you must have observed and experienced something about which you have clarity, you have understanding. You will find you could explain it simply to others in simple terms. If you understand something, a complex thing can be made simple, and you can communicate that simple thing to the people. So what is more important is understanding. And friends, in the process of understanding, if you have any doubt, any query, you please let me know. You can put your questions, your queries in the chat box. And if the organizers allow you, you can unmute yourself and you can directly ask questions from me. But make sure that you are understanding the things. Understanding is very, very important for us as a research student. Okay? Thought two. If you know nothing about statistics, friends, you're missing excitement in your life. Statistics is becoming very, very important, and it's becoming an integral part of life. And in fact, statistics becoming very important in the research. So if you are afraid of statistics, please don't do that. Start loving statistics. Start knowing statistics. If you start doing that, I tell you, you will find a lot of excitement in the life and the research. Statistics, I say, is a journey from data to wisdom. You have a lot of data, and statistics will help you in deriving inferences or wisdom from the data to answer your research questions, your research queries. Okay? So friends, we have to learn statistics to build our own capabilities to derive meaningful results from our data. Very, very important for us. And you cannot do statistics manually these days. So you need some software for it. And therefore, not only you have to learn statistics, you have to also learn software through which you can conduct that statistics. Altaf, you just wait. Maybe I can share the list of the books with the organizers and they can share with you. Okay. Right now, I don't have the list of the books on statistics. Okay, Altaf. And when we talk about research is something, that toss you from one side, one extreme to the other extreme. When I say one extreme to other extreme, it means research is an isolated venture. At the same time, it's cooperative. Many times you will feel that you should be left alone, no disturbance, nothing like that. You want to be isolated. But at times, you want to go to the people, talk to the people, interact with the people. In that sense, I'm saying it's cooperative. So it's a cooperative venture as well as isolated. It's narrow, it's wide. Narrow because you pick up a very, very specific topic. But within that topic, you have to go wide enough to cover all probable dimensions of that particular problem which you are talking about. Research is unstructured and as well as the structured. I mean, if you look up your, if you look at your journey, you will find it's unstructured. You don't know how you are moving, but the output which you communicate to the people, that is highly structured. So it is structured, what is to be done, what is not to be done in research. You can have a formal discussion on it, but what actually you go and do, that is totally unstructured. Research is frustrating and satisfying. There will be times when you feel that फंस गए research के अंदर अपनी वैसी life अच्छी थी, but at the end of the research you will be fine. You will find that you are at the top of the world. The kind of the satisfaction you are going to get, that will be totally unmatched. So it's satisfying, but times it's frustrating. And you have to live in these extremes when you do the research. Research is tossing you from one extreme to another extreme. And your skill is how to manage those extremes, how to manage your frustrations, how to manage your satisfaction, how to manage the unstructured research, as well as giving it a structure. All those challenges you will find when you go for, research. Okay. Research is a journey from known to unknown. What you know today, you start from that place and gradually you move to that which is unknown. And finally, you make that unknown known. So you have to move from your existing position, I'm calling it as a known position, to your future position. What will be that? That's unknown. To do research, we have to design it and decide how to do the research. And components of a research design is you have to define what is your information need, design the kind of the research you want to undertake, specify the measurement and scaling procedures. If you are collecting data through questionnaire, you have to design appropriate questionnaire, test it, pre-test it, and then finally collect data by making use of the data collected through questionnaire. Specify the sampling process and sample size, and finally develop a plan of data analysis. So friend, these are the parts of your research design when you do the research. Before we start today's agenda, let me ask you a question. What is the most important input for research? Any one of you like to respond? Time, data, Rishika. Altaf, we need time for every activity, whatever you do. Saraswati, critical thinking. Rakesh, hypothesis. Okay. I think Saraswati raised this point, critical thinking. This critical thinking should always be with you when you do the research. Please understand the PhD or the research which you're doing. It's a highly intellectual endeavor or activity, which requires a lot of thinking, critical thinking, in fact. Swasti, I'm very happy that you said critical thinking, but that critical thinking should go always. So I'm not saying that the input you require. That's necessary for processing. And data, hypothesis. Hypothesis will come from your research issues, the research questions. That's not the input, that's the thing which you have to answer. Variable, no. Research questions, no. Identify problem first. That's the step which you have to do. What is more important, I think, Rashika, you are right. We need data, information. And we have a very famous quote that says, in God we trust, in absolute we believe. All others have to prove with data. So whatever you're doing, you have to prove it with the information, with the data. And what kind of a data that differs from the issue of the research to the issue of research. Identify problem, that is the starting point. Unless and until you have identified problem, you cannot proceed further. Go read. Research questions, yes. Variables, no. Variables is not an input. Variable is what you need. That's not the input. The most important input which you require is the data or information. And how do we get the data? Data you can collect through questionnaire, which you call as primary. Data can be collected through secondary sources. Data can be collected through experiments. But you need data to prove what you want to say. You need evidence to prove what you want to say. And next question is how to process your data. That will be another problem. What to do with the data? We have to process the data for answering the research questions. दाशी में बात करूंगा. So by using necessary statistical tools and software. Okay, that's why I said in the beginning, to have proper analysis of data, you should be aware of the statistical tools you need, and to process that, what software you are going to use, you have to also learn that software. You can make use of Excel. You can make use of SPSS, and you can also make use of R, and you can make use of so many softwares which are available. Our focus will be on R. Just a minute. Kavita, you have to check volume at your side. I don't know. Shifted means, Altaf, what do you mean by shifted? My mic is where it is. I've not done anything.
Yes.
Yes, Sanshika.
Sir, you are clearly audible.
Okay. So friends, our agenda of the day is we have an idea what we want to do. For that, we have formulated necessary hypothesis testing. We collect the data to answer them. What we have to do is learn statistical tools, learn how to get the results by using the software, and how to get the inference or the interpretation of those results. So these are the three things we are going to discuss. And I hope all of you are charged with energy and concentration while we discuss it. And we shall not be using Excel in the spaces. We shall be using R for data processing. So as a researcher, what is the first thing we do with our data? You got the data, raw data. What should we do? Arrange them. Okay. Altaf, arrange in terms of what? We arrange in the form of tables, in the form of graphs, and charts. Yes, Rishika, you're right. You have to clean your data. You have to prepare your data as per the software requirement which you're going to use. And once that is ready, then you have to summarize your data, understand your data, become friendly with your data. And that you can do if you describe your data by using tables and graphs. They give you a visual feel about the data. What your data is trying to convey, to get a visual feel of it, you will find preparing graphs and charts. Of course, the relevant charts and graphs. They will help you in understanding your data better. And once you understand your data, you can work on that data comfortably to get the inferences for research problems. Okay. So how charts help us in understanding the distribution of observations? So when we say chart, what kind of charts we can make? Give me the names. Anyone? Pie chart. Yes, Rashika. What next? Histogram. Bar chart. Histogram. Stem plot. Histogram with normal curve. Box plot. Okay. Now the problem is you people have named so many graphs. Which graph I have to use for which kind of a data and for what purpose? That's the problem which we are going to discuss. Pooja, it's either QQ plot or PP plot. It's not a QP plot. Either you will have a QQ plot or you will have a PP plot. There's nothing like QP plot. Okay. Now, before I answer or we answer questions, what chart for what kind of a data, we first understand nature of data. How many types of data we find in our research problems? What kind of data we find? How do we, in how many categories you can classify your data? Rashika, can you try? Rashika, primary data, secondary data is different thing. Yes, Pooja, you're right. We classify data into nominal, ordinal, and into a scale data and ratio scale data. Nominal data is your categorical data, qualitative data, and you have gender, okay, rural background, urban background, that kind of a data, that's your nominal data. So when you get the ranking or preference, where you have the hierarchy, you get the ordinal data. These two type of data, on these two types of data, you cannot perform mathematical operations. You cannot say rank 1 plus rank 2 is equal to rank 3. You can't say like that. Male is 1, female is 2. You cannot say 1 plus 2 is 3. You can't add them. You can't subtract them. You can't multiply them. You cannot perform all kind of mathematical operations on this. But these two types of data, collectively, they are called scale data. On them, you can perform all kind of mathematical operations. You can add them, you can subtract them, you can, multiply them. All kind of processing you can do. So most of this software recognize interval scale data and the ratio scale data as scale data. Okay. Now pie chart. For what kind of data you can prepare pie chart? Can I prepare pie chart for the scale data? Nominal and ordinal. I cannot prepare pie chart for the scale data. Similarly, bar chart will be prepared for nominal and ordinal. Histogram. Histogram. Histogram for interval scale data, or I will say scale data. And what is the purpose of preparing scale data? Sorry, what is the purpose of preparing histogram? Yes, Rakesh. Kavita Sardana. Frequency. No. What is the purpose of preparing histogram? To check what kind of distribution my data is following. Is it normal or it is not normal? Similarly, box plot is also prepared for scale data. And it also gives you an idea about the distribution of the data. The stem plot is also for scale data and gives you an idea about the distribution. The stem plot is rarely used. Most widely used are your histogram and box plot for the scale data. Pie chart, bar chart for your ordinal and nominal data. And that's what we'll be looking at. Yes, Pooja. Pooja, what is the advantage of using box plot? What box plot tells us? One, you said by using box plot, we can identify outliers. Yes, Madhu. Madhu, anything else? Skewness. Yes. Data symmetry. Rashika, skewness, symmetry, they are one and same thing. Normality. What else? Okay. That's a typical displays variable location. Yes, Pooja, that's great. And that locational variable measurement is what? Central tendency. Okay, this is Q1, this is Q3, this is Q2, which is your median. And many times you'll find softwares, some softwares gives you a value about the mean. So either they put at a dot to represent the mean, or they can draw a separate line to represent mean. But a typical box plot will show this line as a median line, which is a measure of central tendency. This is quartile 1, this is quartile 3, and what is quartile 3 minus quartile 1? What is it called? Quartile 3 minus quartile 1. Interquartile range. Yes, Sakshi, interquartile range. And higher this range, more variations. Lower this, less variation. So box plot is a very, very powerful plot. It tells you so many things. It tells you about central tendency. It tells us about dispersion, skewness, outliers, normality. So many things in one graph, and that's why you'll find box plot is very, very important for us. And of course, histogram can also, okay, I make two graphs, two box plot. One is this. How do you react with A and B? What do you see in A and B? And if we have a third graph, which is like this, what you will say? This is in between, exactly in the mid, symmetrical, normal. These two are skewed. Distributions. So one is positively skewed, another is negatively skewed, but they are showing the skewness of the data. And how do we, so histogram with the normal curve, something like this. And you can have box plot. And these whiskers are drawn as Q3 plus 1.5 interquartile range, Q1 minus 1.5 interquartile range. This is for upper limit. This is lower limit. That's outlier. You can draw box plot horizontally or vertically, that's your choice. You can also use it for comparison purposes. That can also be done. Okay. So before we go further, let's see, how can we make this graph by making use of RStudio? I've shared the files, and you can work with me if you wish. Okay, let me open up a file. Okay. To begin with, we have to open up a file. So these are the commands which we are going to use as a file, and the data is in Excel file. So you can write the command here, or you can download by using the file option, which is here. Okay. And then I'm saving the data in a file which is called mark file. Then I'm defining a mark as a data frame. I'm converting my marks into data frame so that I can do processing quite comfortably. So let me open up the Excel file. Just a minute. So I go to file and import data set from Excel, browse, and marks in maths and computer science. Then I don't know whether it allow me to change it or not. The name I want is marks. Mark. And that's the data we have. We have the student data of marks in maths and computer science, and we have gender of the students, whether they are the male students or the female students. Okay. Right. Then I take this command. This is the command that will convert my mark to data frame. So I copy it here. And if you see the structure of marks and summary, so this is the structure. Marks is having a data frame is having 3 variables: marks in math, which is numeric, marks in computer science, numeric, and the gender is a character of the string. minimum marks in maths is this much, computer science this much, and that's your gender. I'm going slow, and we can, if you have any question at any point of time, you please let me know. So since I'm working with the mark data, so I attach it so that I need not to refer it again and again. Then mark in the first column is having maths mark, so I'm separating it. So from the data frame of maths marks, which is having maths marks, computer science, and gender. That's column 1, column 2, column 3, column 1. So I'm storing the marks of column 1 in maths mark. Okay. And let's see how do we do that. These are the marks which we have in maths. Then we have a summary of it. So we have the mean, first quartile, median, mean, third quartile, maximum. Similarly, I can calculate for computers, and that's the summary for the computers. Kavita is asking why to convert in data frame, because data frame will help us in identifying each data separately. Another thing is, in this data file, some variables are numeric and some variables are characters or a string. You cannot define in any other thing except data frame combination of the nature of the data. And that's the reason, Kavita, I converted into data frame. Okay, then we have, let's make simple frequency table. And the command is very simple, table. I store it and then I can see it here. And similarly, you can use get the table frequency of the maths mark only, and I show you how we can do that. And if you see what is there in the frequency, that's it's a cross tabulation because we have two data in it, the maths marks and the computer science. So it gives you the cross tabulation of both. Kavita, yes, it's similar to what we are making in the matrix. So actually it's a vector, and because I'm taking only one column, therefore I call it a vector. Attach command do, if you don't use the attach command, then you have to refer the name of the data frame again and again, and you have to write the name of the variable with the $sign. So mark is my data frame, then the $sign, and the name of the variable in that particular data frame. Unless and until you write the marks before the variable name, R will not recognize to which data frame you are referring to. So either you attach it or you define like this. Attach many times create a problem. So you will find those who are experienced programmer, they use that $sign command. So data frame, and then variable name. Okay. Then similarly, I can make a frequency distribution for the marks in maths. And the output is coming in a horizontal fashion. I don't want it in the horizontal fashion. If you don't want it in the horizontal fashion, you want it vertically, then you have to define it as a data frame. So if we define as a data frame, then you can see the output is coming in a vertical format like this. And that's the frequency distribution which we get. Similar exercise I can do with the computer science marks. Table, frequency, data frame. So simple frequency table you can make. And command is very simple. You have to write table and then variable name. And you will immediately get the frequency distribution. Then I want proportion of the frequency. So what I do is I have already got the frequency of the maths. And I need proportion of it. So my command is proportion.table. So now you will get the frequency, relative frequency. And if you want in terms of percentage, you multiply it by 100 to get the result in terms of percentage. And I show you how can we do this. So just run it. And this is the percentage. And if you want to see both the frequency and the relative frequency, then you have to combine. You have to use a command which is combining your frequency in maths and percent frequency in maths. And then see the result. So I run it. And here you will get, frequency and relative frequency. If you want cumulative frequency, then you can calculate cumulative frequency by using the command CUM, sum, cumulative sum, and frequency of maths. And if you want percent of it, then you can take the percent of the cumulative. And then I need a table for all the four: frequency of maths and cumulative maths, percent maths, cumulative percent maths. I've written frequency of maths 2 times, so I'm leaving it once. Okay, I have to first run that. So this. Now you can see all the 4 data pieces are there. You have the frequency, you have the cumulative frequency, you have the relative frequency, you have the cumulative relative frequency. Ripu, I'll call you later, right? So the basic command which I'm using here is table, proportion table. Then combine and simple table. So friends, now I think you can create frequency tables and relative frequencies and cumulative frequencies by using simple command of R. Okay, now let's make a class frequency distribution with class interval. So if you get the maximum and the minimum and the range, you can get an idea. How many classes you have to make, and in those classes, how many, how much class interval you keep in each class. So I'm defining class interval as I'm saying cut much of marks into 10, right, false. Right, false means that right figure, if you say 10, 20, then 20 is not included into the class interval. So therefore they say right is false. Minimum is 20, maximum is 29. So range is 79. So if you make 10 categories, so by and large, it will take class interval of 8. So then you can make table according to the class interval. And now you can check. And since I get the frequency distribution, I can make the pie chart of the same. Simple command. A similar way you can do for the computer marks, get the range and cut it into 10, then table, make, this is the table which you get, and convert into data frame, and you make the pie chart. Okay. Suppose this is the class interval which is generated by the system itself. I don't want that system to generate their own class interval. I want my own class interval. So I can define it, sequence 0 to 20 and go up to 100. So make a class interval starting with 0, increment by 20 and go up to 100. So if I make this Now you can see 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. And then you can have it, it's percent, and you can also have it this. And that the overall, when I bind everyone, suppose I want to make the similarly, I do it for how to make pie chart of it. Simply pie data frame of it. Okay. Then the pie chart we get for the computer science marks frequency distribution. Very simple. If you want to make a bar chart, bar plot bar. Bar plot. The command is bar plot. Now you can make a bar chart of it. Simple bar plot. Then we have here the marks, proportion marks in computer science. Hold on. Then you can make bar chart. So my P is a bar plot, and I label it, I put grade into it, box it, and I get the result. To make a box plot, the command is simple, box plot. So if I write here, box plot mark that the box plot. Kavita, what's your question? Right argument means what? Right. Right means that the right value is not included in the class interval. So if you say 10 to 20, 20 will not be included. This will be up to 19.9999 like that. That's the meaning of the right argument. Okay. And I can make a box plot here. for gender. So I'm getting maths mark for male and female as well. So what I said, make maths mark for gender. Now you see I'm using that mark $sign gender. And I have specified the color, gold and dark green. If you want another color, then you can define any other color. Histogram, simple command, hist. So if I type here, hist maths mark, you'll get the histogram. Simple command, not complicated. But if you want to give it a color or want to make it attractive, then you have to fight with the graph. So whatever command I have for the graph setting, I'm offing them. This is the frequency distribution of marks in maths. That's for the computer science. But that's not sufficient. We have to make graph with normal curve. And to define normal curve, we have to define its mean and the standard deviation. Because to define a normal curve, you need two parameters, mean and standard deviation. It depends upon the nature of the variable. I should show you. So for example, if I want to make a pie chart of gender, gender mark. I think I have to convert them into numbers. It's not taking numeric string value. So I think I have to convert them into number. Then it will take it. Let me check if I have the data. It's not necessary. I will show you. Just a minute. I think I need to find out the data set which I have with me. Okay. I just import this data file, data set 2. Kavita, just give me a minute. I just trying to open up the file. I define this card data. And if you see the hard data treatment of anger is 1 and 0. So if I make a pie chart of it, pie hard data dollar now. Do you see this? It makes a pie chart. If you want table of it, you can make a table of it. Say tab to table hard data dollar treatment of anger. Now you can see the frequency distribution table of the data. So it's on you, not necessary that you have to first convert it into data frame and then you do it. It's not necessary. But can't we make pie chart of the string variable? No, Kavita, it's not. I've seen, I'm not able to make the pie chart with the string. At least I'm not aware of it. Okay, so let's make the box plot now. This is the mathematics and computers. That's what we get. If you want, you can right. If you want a histogram with the normal, you have to first define normal curve. And to define normal curve, you need the mean of match of mark and standard deviation of match of mark. Because to draw a normal curve, you need 2 parameters. Okay, so I show you here what you can do. That is histogram. And then I define X, which is the minimum and the maximum, mean of it. Then I draw a line, which is this. Similarly, for the computer science, define X, the frequency distribution, and draw the corresponding line. Kavita, what is your stake about the distribution? What kind of a distribution is it? Skewed and not normal. Kavita, it's a negatively skewed or positively skewed? Which is positive, which is negative? This is my A, this is my B. Positively skewed. My yes, it's a leptokurtic because it's having more peak. Not distribution, it's not normal, that's what it is. And if you want, you can make a frequency distribute the histogram with frequency polygon. So I just put it here. Then lines will be the midpoints of your, the class intervals. And that will be the polygon. Combined minimum of P breaks and the mids and the maximum breaks. And then you draw it. Okay, so you can make graph easily. Bar plot, box plot, pie, and histogram with normality. All those things, it can be done easily. Okay. So once we are through with the graphs, then we have to come out with the descriptive statistics. And in descriptive statistics, what we need measures of central tendency, dispersion, symmetry, and pickedness. And let's see how do we calculate it using R. Very simple command there. So first you can calculate the summary. Summary itself gives you a lot of information like minimum, first quartile, median, mean, third quartile, and maximum. If you want only mean, you write mean and marks. So getting mean, the command is mean. Getting variance, the command is var. So if you want marks mean here, mean computer marks. And if I want variance of maths marks, that's the variance. Similarly, you can get the variance of the computer marks. Right. If you want a standard deviation, the command is simple standard deviation, which you have SD. SD for standard deviation. So we are using commands mean, variance, standard deviation. Okay, I have an interesting question here. The standard deviation of maths is 17.18. The standard deviation of the computer science is 15.31. So friends, I have a question for you. If you are a teacher and you design a paper and you get the marks of the students with larger variation, will you appreciate the quality of the paper? Kavita, Sakshi, Mahima, Altaf, Anita. I repeat my question. You are a teacher, right? You have said a question paper. Two question papers, let me say. In one question paper, your variation of the marks is very high. In another question paper, your marks variation is very less. So will you like to have more variation in your mathematics marks, or sorry, more variation in the students' marks, or less variation in the students' marks? That's my question. Okay. Less variation, less variation, less. Altaf, less. Rupali, less. Okay. Now the question is, I don't accept anything unless and until you give me the reason for it. Mahima, great. Mahima, why do you say more variation? When everyone is saying less, why did you say more? Mahima, can you unmute yourself and speak? Mahima, can you give me the answer? Why do you want maximum variation? Okay. Because it will give me difference between students, so I'm unable to unmute. Okay. Right. So, Mahima is absolutely right. We look for variation in the marks. If all the students, imagine, no variation in the marks, everyone gets 60, 60, 60, 60. And if you get, some students are getting 90, some students are getting 60, some students are getting 30, like that. So then you will find that the question paper which you have set, the examination which has been done, this examination is able to distinguish between intelligent students and average students and poor students. And if you have no variation, you are not able to distinguish between the students. High reality, high and low is very low, right? And this is the problem we are facing in the online examination. Almost every student is getting in the range of 80 to 90%. Everyone. I mean, if everyone is getting 80 to 90% marks, I mean, how do I distinguish who is truly intelligent, working hard, and who is not working hard? And therefore, variation is better in that particular case. Less variation is not particular in that very not desirable. But don't conclude that more variation is always good. Mema, what's your background? From which background you are? Kavita, Jahir Abbas, can you share me your background? Education. Yes, Mahima, that's why you were able to answer this question correctly, because you understand the importance of the examination system. Kavita, economics. Okay. Kavita, suppose I take the share prices, right? And they're having huge variation. Like we find 2 days back, the market gone up by 2,700 points. Sorry, gone down by 2,700 points. And tomorrow, yesterday, it has gone up by 1,300 points. So if you find a lot of variation in the prices, good or bad? Kavita, in that case, what do you say? Is it good or bad? Variation, bad, because variation is also understood as a risk. More variation, more risk, and that's why it is not desirable. Okay, so we are able to calculate the mean, median, and the variances. Now, skewness you can easily calculate. No, quantize you can get range, maximum, minimum, and for the skewness, the formula is simple. Whiteboard. If you see here, so if I want skewness, so simply type SKE. Skewness, maths marks. Sorry. I think I have to arrange I have to install a library. Just me check. I need a library, and I have to see which library I need. I think I need to install FBasic library. I go to tools and install packages, FBasic. Then library. Okay. Capital is P is capital. I don't know why it is not taking. Okay, FBasics. FBasics. Then I think I can make use of skewness, maths, mark. So the skewness is positive, and the method they are using is movement-based. Parameters are not identified. The variation in exogenous variable is not positive. Kavita, variation not necessarily mean positive or negative. It has to be there because higher the variation in the data which you have, better will be the quality of the estimates. So yes, you're absolutely right. I cannot generalize whether variation is good or bad. There are instances where variation is good. There are instances where variation is not good. So you're right. So if you want kurtosis, you can calculate kurtosis and say maths mark and that the kurtosis. And 4.54, that shows leptokurtic distribution. So friends, if you want to calculate these kurtosis and skewness, you have to install a package, which is FB capital basics. Once you enter it, then you will get all, things. So friends, you can easily calculate the descriptive statistics and the basic statistics by making use of R package. And you can also make the relevant graph by using R package. If you still have a question or a doubt, please let me know. Any questions? Any doubt? Any query? No? Okay. So friends, let's have a 10 minutes break. And after the break, we will come back and meet. Okay.
Thank you, sir.
So 10 minutes break. And after the break,
Thank you, sir. To all the participants, kindly stay tuned and we will be continuing after 10 minutes.
so friend, let's continue with the positive energy. And we are here to learn, and it's time to learn. And important is patience. As a student, as a researcher, you have to have patience. No substitute. And patience means what? Waiting without tiring of waiting. You have to wait. Patience means you have to wait for the results without tiring of the waiting. And what Sai Baba says, Saburi, patience. And that's very, very important for all researchers. So let's move ahead, and we are going to talk about now what is called regression. Kavita, it is said regression is like a woman. You never understand it fully. When you think you do, the next model is entirely different. And nobody can say that I'm really know everything about econometrics. Difficult. Which software is better for biological research, RStudio or SPSS or any other? Chandraprabha, I don't think SPSS will be more useful because SPSS is for specially designed for social sciences. R, of course, you can make use of because R is more versatile and you can do a lot of programming in it, and you can make use of it. And if you have heavy calculations, you can go for MATLAB or Mathematica. They can also be used. Altaf, for finance, I don't know what exactly you want to do in finance. And if you are working with econometric modeling, then you can make use of Stata or EViews. Yes, time series data, then you can make use of EViews. EViews is very good for time series analysis. But it's not a free software. You have to work with it. And no programming is required for EViews, but if you are comfortable with the programming, you can also make use of R. R requires a lot of programming. You have to learn a lot of commands and specific libraries which are to be used. But EViews is more friendly. Click, 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 menu driven, and you feel very, very comfortable with time series analysis with EViews. Okay, so Kavita, I'm not working in the Stata files, so I don't have the two files, but I can share with you R files. Data files I've already sent to the organizers. They might be sharing with you. And R files I will share with the organizers and they can share with you. Okay. And Kavita, that's another beauty of Stata, that you can very, very comfortably store your commands in a do file and make your whole process automated. Okay. Gurvika Rao. Gurvika Rao, why do you say that patience is not important? Gurvika, why do you say that patience, having patience inappropriate? Okay. No intention. Okay, regression is like a woman. Okay. Okay. Anyway, but people say that it's very difficult to understand a woman. I mean, it's not sexist, I will say. It's just in a lighter way, they are saying it. Garvika, please don't take it otherwise. Of course, I understand it's a gendered-based statement. Okay. Anyway. So that's our next agenda, regression analysis. In regression analysis, we have one dependent variable or called the explanatory variable, and we can have more than one explanatory variables. And dependent variable is normally represented by y. Explanatory variables are represented by x1, x2, x3. And we believe that xy is the function of x1, x2, like that. That means x1, x2, x3, etc. They causes y. So y is the effect, and these are all causes. Regression analysis can be used for Shubham, I don't think from my side voice is cracking. You please check at your end.
Yes, sir, your voice is audible and very clear.
Ah. So regression analysis is helping you to study cause and effect relationship, where effects are denoted by Y, causes are denoted by X1, X2, and so on. So let's start with our regression model. First, I will be taking the simple classical regression model that says yi is equal to alpha plus beta xi. Alpha is my intercept parameter, beta is my slope parameter, and this is your error term, which is also called disturbance term or also known as noise term. And every regression module is stochastic in nature because of the error term. The error term which we have here, this error term, its behavior is random. Stochastic means probabilistic. And since this is my error term behaving in a random fashion, my y also move in a random fashion. And that's why the model is called stochastic model. And this error term takes care of other things being constant, ceteris paribus. Because you cannot take all the variables into your model. You can take some of the variables and all other variables you believe they are constant, and they will be pushed into error term. And अंशिका कविता को जरा अनम्यूट करना अगर पॉसिबल हो तो.
Yes, sir, I'm doing. So she can mute now. Unmute now, sorry.
Kavita,
Yes,
can you tell me the assumptions which we make here. One,
Linearity in parameters.
linearity in parameters. Okay.
Random sampling.
Random sampling. What else?
Variation in X.
Variation in X. Kavita, are you sure these are the assumptions?
Sorry, sir?
Do you believe that are these assumptions?
Yes, sir. These are assumptions.
Random sampling is the assumption.
Yes, sir.
Are you sure?
Yes, sir.
I mean, random sampling is not a specific assumption of regression model. Wherever you take a sample, we say you should take always the random sample.
Sir, it gives IID random variable. That's why we make the random sampling assumption in classical linear regression model.
But why IID? Because of what?
For doing asymptotic analysis.
No. But what is that which ensures IID property?
Sir, error term is, we say that we have random sampling that results in
Yes, you should
an IID random variable, independent identically distributed
you
random
should say
variable.
expected value of the error term is 0.
So that is the fourth assumption, conditional.
Variance of the error term
is constant.
Constant.
And normality.
Error term follows.
Normal distribution.
And the moment you say normal distribution, what does it mean? It's a random variable, right?
Yes.
And its normal distribution, what does it mean? Zero, constant, covariance between error terms is 0. So that means IID property. Error terms follows IID property, right? They are
Yes,
independent. Having 0 mean constant variance,
yes, sir.
normally distributed.
Yes, sir.
And IID, friends, it means independent and identically distributed. And most of the assumptions you will find is with the error terms. Error term is now, Kavita, I'm not very particular which is the first assumption, which is the second, third, fourth, but I'm putting them all I'm putting here all the assumptions. So friends, we assume that the mean of the error term is 0, variance is constant, covariance among the error term is 0, covariance between x and the error term is 0, error term is normally distributed. We also assume that x's are given to us, they are non-stochastic in nature. These are the assumptions which we make for our regression model. Okay. And Kavita, I'm not talking about here linear in parameter because that may make things a little complicated. Yes, Nadia is also saying homoscedasticity, right? No autocorrelation. Yes. And challenge is how to estimate the values of alpha and beta. And for that, we make use of either you can make use of OLS, ordinary least square method, or maximum likelihood method. For the simple regression model, both gives the same results. थोड़ी देर में कॉल करूं मैं थोड़ी देर में कॉल करूं मैं and we will concentrate on OLS. And most of the software by default use OLS. Do we need to check these assumptions on residuals, Ganga, Sushil, Warrior? The answer is yes. And it's very important, your model is, your conclusions will be valid conclusions if your model is perfect, and your model is perfect when your assumptions are true. If your assumptions are not true, model will not work properly, and there will be a question mark on the results which you have obtained. So testing of assumptions is very, very important. So I do not know whether we will be able to get the time to test the assumptions. Okay. There is an important theorem which is called Gauss-Markov theorem that says the estimate which we get through OLS these estimates are blue estimates. By blue estimates, we mean best linear unbiased estimator. They are best because they are unbiased. They are best because they are consistent. They are best because they have minimum variance. And therefore, given a choice, we always prefer OLS, provided all the assumptions of the models are true. They are linear, unbiased, efficient, consistent, and sufficient. And that's why we say OLS estimates are best estimates. Any question before we go ahead? We define model. We define assumptions. And the method of estimation is OLS, ordinary least square method. And we use this method because this is the best method and its estimates are called blue estimates. Kavita, where do we use regression? Where do we use regression? Where we are studying cause and effect relationship. So friends, wherever you are, wherever in whatever field you people are, if you have a problem which is associated with cause and effect, then you can use regression model there. Yes, Kavita, causal relationship. So let's apply our learning and see how we can make use of R to do the regression analysis. Right. So I think I have a file with the name of debt equity ratio. It's a CSV file. So you can read that CSV file by using this. Header true, that means the first row is a header row. So if I run it, then I can browse the file. So if you want to see the structure of it, that's the, sorry. So we have two numbers here, the debt equity ratio or the beta of a company. Okay, I mean, you can think them like X and Y. So what I do is I can convert them into X and Y and can work it. Kavita, where you are teaching, you can see the bottom 10 observations. You can see the top 10 observations of the data. Terry. Okay. Then I hope you remember what was the function of attach. When you attach the data which you have with which you are working, then you need not to refer it again and again. Okay, you can make a plot of it. Plot means scatter plot. If you want color, I can use some other color, say red. That's my scatter plot. Okay. Then to run regression, the command which we use is LM. LM stands for linear model. Okay, so first we write dependent variable followed by independent variables. That's the structure of the command which we have here. Terry, do you know Montubos? Kavita, do you know Montubos? Yes. So result I'm saving in, the result of the regression I'm saving in a variable that's result. So I just run it. If you want to see the result, that's the result. So this is the value of the intercept and this is the value of the and if you want to see the summary of the result, that's the summary of it. So you have the intercept, you have the standard error, t-value, the probability value, the residual standard errors, and multiple R square, adjusted R square, F statistics, all information you will get here. I mean, you can do it simply. Command is quite simple. Command is LM for linear model, bracket. You have to first write your dependent variable. Do you recognize this sign? Tilde sign. It's called the tilde sign. Where do you see here? Where do you see this sign on the keyboard? It is above tab key. So to activate this, shift the key which is having sign, this. After that, you write independent variable. And if you have more than one independent variable, say, then you write x1 plus x2 plus like this. That's the regression equation. And you can save the result in some variable name and you can get the summary of the results. Like this. And if you want to fit a line, the regression line here, then the command which uses a line, AB line. Okay, so you will see the line fit, the regression line is being installed. And if you want to read suppose I take another file, which is, I'm importing the Excel file. That's in cost function. Let me see what is the name I've used here. Cost data. Import. So we have the firm size, and we have the cost, and we have the input. So we say that the cost is a function of the input. So if you want to see the structure of the cost data, you can see the structure. So we have three variables in it, cost, input, and the size of the firm. 0 means small size company, and Y means 1 means big companies. A blind must be giving predicted Y. How can we get the predicted residuals? Okay. Kavita, give me a minute. I will tell you how to save your residuals. And so I this is the cost. I'm plotting the input and the cost. That the behavior which we get here. And if you want to make a graph according to the firm size, 0 blue, otherwise red, and for that we are using a command if else. So that's what you will get. And now you can see here. So you have data for blue one, you have the data for this one. Okay. Just a minute. Then recall the command lm that's cost tilde sign the input, then you will get the result of it. Okay, I have not attached, so I have to attach the cost data. Now I can run it. If you want to see the result, you can see the result. If you want to get the summary of it, you can get the summary of it. And you can put the line. And I fit the line when this firm size is 0, and If the firm size is 1, the line will be like this. So not much difference between the behavior of the, I think, let me delete it. Okay, sorry. You first have to make the scatter plot, only then you can make use of it. So almost same we are getting here, not much difference. Okay. Then, okay. If I want to save the resi, sorry. Uh, Kavita, the command for residual is resid. Okay, so then you can test for, okay. So I think simple regression is quite clear, no problem in it. Just give me a minute, Ganga, Sunil, Sushil. Okay, just give me a minute. Maybe we check for homoscedasticity. Okay, before that, let's go for multiple regression where we have more than one. So I just select I don't know how it's not coming. I'm just opening that file. Friends, give me a minute. In the meantime, if any one of you have a question, please let me know. Head to Friends, I think some problem is there in my R studio. Now it's not working. I have to yes, now it has come. It should not be in the inverted commas. Kavita, have you tried for Gretel? Yes, so you can see the structure of it. You have the sales, you have the price, you have the advertisement. You can attach it. And now you can see the command. The command will be LM, the linear model. My advertise, then my dependent variable is sales, and the independent variables are my advertisement and price. Let's see how do we do it. So we have LM data. Data is the name of the variable. So it's a data frame. And from that, I'm picking sales. Even if you have it, I think I can also put it similarly. Since I have attached this file, this data, I can simply write sales advertisement. Since it's a multiple regression, so all the independent variables will come with plus sign. Then that's the summary which we get here. And if you want to make the scatter plot matrix, the command is pairs. You can get the correlation matrix. Kavita, I have to check whether what command we have to use for calculating robust errors. Okay, I'm not sure about that particular command, but I'm sure there should be a mechanism to calculate robust error. Okay. Then you can save the residuals, resi output 1. You can also get the predicted values. For the predicted values, we get the predict. And then you can see the first few figures of predicted values. Then load this, make histogram of the residuals if you want. That the residuals. And for making the normal distribution in it, you can do the curve here. So I think let me repeat these steps which we are doing so that you can appreciate it. LM y x1 plus x2 this will give you output or the result. To see the result, you can take the summary of it. Small. To save residuals, suppose I use command residuals, that will be equal to resid. Your output. And to save the predicted values, the command is predict output. And to check the normality of the residuals, you can make the histogram of residuals. And that histogram will give you an idea whether the distribution is normal distribution or not. Okay. To check whether it's a normally distributed or not, which test we use, Kavita? To check normality, which test we use? Which test we use? Madhu is saying KS, Shapiro, okay. Widely used one is Jerek-Bera test, JB test. Kavita, have you used Jerek-Bera test or JB test? So Kavita, which test you people use for testing normality? Anyone else? Okay. But we use Jerek-Bera test. You can use Jerek-Bera test for the and asymptotic p-value is more than 5%. That means distribution is normal distribution. Okay. Let me take another example. And I'm installing a package car library. This car package helps me in identifying VIF. VIF is used for what? Anyone? Variance inflation factor. VI stands for variance, inflation, factor. Madhu is saying to check multicollinearity. Yes, Kavita. For checking multicollinearity among the variables, we use VIF test. And to have VIF test, you have to download a package called CAR. And you simply write VIF of the output. And for advertisement, it's 1.069 and the price. Sakshi, standard error. Sakshi, VIF is not for standard error. It's for testing multicollinearity. And for heteroscedasticity, we use Bruce-Pagan test. And to use Bruce-Pagan test or BP test, you have to download a library with the name of LM test. And then the command is BP test. So I install the LM test, then install the library, then run this BP test. It's asking me to download that's my BP test. 0.2763, that means the model is not, yes, Kavita, it's a LM test. And this is, Kavita, I don't know in what sense you are using LM test. LM test we use in panel data also. But here I'm talking the context of heteroscedasticity. Okay. Now, Kavita, we have a question for your answer for your question. And to estimate the robust error, we need another package which is called sandwich. So this has to be installed. Just wait, the package is being installed. Then library, then coefficient test output, and it's a variance, covariance. HC is a heteroscedastic consistent estimate. So V for variance covariance matrix and HC for heteroscedasticity consistent estimates. So you estimate the coefficients. Then the standard errors which you get now, I can show you. Summary. I think let me take a completely new exercise here and see what we can do here. So I import a file, Excel file. And friends, now I will be telling you how to do it stepwise. I have the salary data, which is the function of rating, experience, and certification. So I import it. And that's the data which we have with us. Then I attach salary, then output 1, LM, before that, let me check this structure because I don't remember the name of the variables. So structure, salary, so we have salary, annual, average performance rating, experience in years, and certification. So out 1 is equal to LM salary annual, then the tilde sign, average performance rating plus experience in years plus certification. And if you want to take the summary of output, that the summary of output, all the variables are coming to be significant. And you can save the residuals. So I say res1 is equal to resid out 1. Then I can make the histogram of res1, and that the histogram of it. Then I can perform Jarek Bera test res1, enter. So the p-value is 0.7863. That means distribution is a normal distribution. We can check VIF of output 1. And that's the VIF value. And we can use Bruce-Pagan test, BP test. Sorry. Out 1. So it is heteroscedastic. So I think we are able to check our assumptions, and we can also get an estimate of the robust errors. Okay. Any questions if you have? Any doubt, any query? But I tell you, if you want to work with R, you have to do a lot of practice, because even we don't remember many times the commands. So, okay, how do we interpret the p-value here is this much, more than 5%. Sorry. More than 5%. That means null hypothesis of the BP test is that error term follows homoscedastic behavior. Rejection of it, it is not homoscedastic, it is heteroscedastic. Since I'm not rejecting my, so I'm accepting null hypothesis. That means error term is following homoscedastic behavior. That's how we interpret this. Ganga Sushil, is that clear? Okay. Any other question? If you ask me personally, for panel data, I will suggest we should go for Stata. Can we test endogeneity? Kavita? Kavita? Can you unmute yourself?
Sir, rights, I have given the rights to her. She can unmute.
Sorry, sir. What is the question?
You're asking me, can we test endogeneity? And my response is, we cannot test statistically endogeneity. Theoretically, you have to prove whether endogeneity exists or not. Otherwise, if you take any, if you calculate the covariance between X and error term, that will always be 0, and you cannot prove endogeneity. So you have to take it. Uh, Sakshi, I'm not remembering a particular book doing regression or statistics with R. There are a lot of books, but I can share with the organizers maybe Monday or Tuesday, not before that. So friend, that's all from my side. If you have any question, any doubt, please let me know. Thank you everyone, and all the best to all of you. That's all in this session.
Before we end the session, I take this privilege to thank our very dear Professor C.P. Gupta, sir, for being a wonderful resource person. And it's always my pleasure to listen you and understand the new concepts. Thank you so much, sir,
Thank
for
you,
giving us your
Anshika.
time and explaining all the concept in so much detail and taking up all the queries. Thank you from my side and from all the organizing team, sir. Thank you, sir.
Thank you. Thank you.
I can see Anjali ma'am. Anjali ma'am, can I end the meeting for all?